Welcome to episode 300 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Burving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing okay. I guess maybe we should make a little note to the listeners that we're recording 2 episodes today, and we actually recorded next week's episode 2 hours ago. So we need to try to not refer to it, otherwise listeners will be very confused.
I wasn't going to refer to it. You just did, though, by bringing it up.
I guess so. Well, next week, listeners can look forward to hearing about SPAC, which is a new package, or not new, but a package manager they probably haven't heard about yet.
New to you.
Yeah, new to them. New to many. Okay, well, at the top of every episode, I like to read a piece of feedback. We got this email from Ryan saying, "Hi, Rob and Jason. If you want to host a guest who promotes ABI compatibility, you should invite Linus Torvalds. He probably is not. He probably doesn't care about it in the C++ context, but he's very passionate about ABI compatibility as a concept. And we do not have Linus on today, but we do have another guest who cares a lot about ABI compatibility. I might be interested in having Linus on sometime, maybe. What do you think?
No, I don't know. I mean, he's famously antagonistic towards C++, but
that's true.
It's also been, like 20 years or whatever since he made his worst comments about C++. Maybe he's, his mind has opened a little bit since then. I don't know.
Maybe something to think about. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Marshall Clow. Marshall is a longtime LLVM and Boost participant. For many years, he was the code owner for libc++, the LLVM standard library implementation. Until last year, he was also the chairman of the library working group of the C++ Standards Committee. He is the author of the Boost algorithm library and maintains several other Boost libraries. Marshall, welcome back to the show.
Thank you very much. It's glad to be back, and I'm honored to be chosen for a big round number episode. 300. Wow.
People have been asking us for like 30 weeks, what's your plan for 300? And we didn't have a plan, but we developed a plan.
300 is impressive. I mean, once a week, that's 6 years almost.
Yeah.
Well, and we missed a few weeks, so it is 6 years.
Okay.
Well, over the past 2 years, we've been much more consistent.
Yes. But in the first, we would miss one out of every 6 or something like that, maybe back in the day. Yeah.
Still, that's a lot of work. I'm impressed.
Thank you.
Yeah. I am curious, since you said that for a long time you were code owner of libc++, I'm just curious, when did you get involved with libc++-ish?
2012-ish. Yeah, about 2012. I started contributing to libc++ about that time frame. And the principal author of libc++ at the time was Howard Hinant, who was working at Apple.
Okay.
And Howard has been doing C++ standard library work for a long time. He too was a standard library chair. He was a standard library chair when C++ 11 was shipped, and he's the author of move semantics in C++.
Right.
And so I started working with him on libc++, and then he left Apple and went to work for Ripple, and didn't have time to do libc++ anymore. And so I stepped up and basically led that project for 5 or 6 years.
So I'm sorry, go ahead.
Oh, and Howard is still around. He doesn't contribute much anymore, but he answers questions about why is this thing done this way and so on. And then I kind of burned out towards the end of the C++ 20 death march. It was like, doing committee work to get C++ 20 out the door and working on libc++. And I had some turmoil in my work. And it was just like, I need to some of these responsibilities.
It's understandable.
Is there when you joined it, was libc++ fully functional, or did you ever find yourself going, oh shoot, I don't have that, whatever feature, and we're still like in the bootstrapping kind of phase?
we were not in that bootstrapping kind of phase. I mean, there were bits and pieces that were not implemented, and obviously for C++ 14 and 17 and 20, there was a lot of new functionality added. But no, it wasn't very much like there were large chunks missing. Howard did a really nice job.
Okay.
It helps that I believe his third standard library implementation. I don't know where the first one ended up. Okay, but
I haven't even implemented one yet.
But he wrote the one for MetroWorks while he was an employee there, and that was back in the 90s. So he's done this more than once.
Wow.
Yeah. All right. Well, Marshall, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about the C++ ABI. Okay.
Okay.
All right. So the first one is a blog post on the Visual C++ blog, and this is finding bugs with ASAN patterns from open source projects. And we've talked a lot about how Microsoft now has ASAN as a built-in analysis tool in Visual C++, which is really great that they were able to bring this in from Clang. And they just ran it against a couple open source libraries and found a few bugs, and were able to show those to library owners. And I think all of these have been fixed.
That's what it looked like.
Yeah.
Mm-hmm. I'm really happy that Microsoft has this in libc++. That's a great thing. Or not libc, excuse me, in Visual Studio.
Mm-hmm.
I'm a little amused that they're talking about it as if it's new in 2021.
Yeah,
I went back and researched, found an old blog post I wrote, basically running the libc++ test suite under ASAN to find bugs in ASAN. That was March 2013.
This article, made me a little sad because these bugs that they're finding in open source projects, I'm like, wait a minute. Are you telling me that OpenSSL does not currently run their full test suite with an address sanitizer enabled? That's like world ends kind of problem if OpenSSL has an unknown security flaw, or known by a small group of people security flaw.
Or an out of bounds read or write, yes.
Yeah. Now, to be fair, that bug that they found, if I read that correctly, was a bug in the test suite specifically.
Okay.
But still, they should have. It should have been caught sooner. Yeah.
And when I ran ASAN for the first time against libc++, I found a couple of bugs in the libc++ test suite.
Right.
I will mail you the link to that blog post, or you could search for, search the LLVM blog archives for like March 2013, and you'll find it. And it's like, there was one real bug in libc++ that it found. And it had to do with something deep in IO streams, where when you were starting up a stream, it would allocate a 0-byte buffer on the heap and then write 1 byte to it and then resize it. Nobody ever saw any problems with this because, on macOS, heap allocations always get rounded up to a multiple of 16 bytes.
Even a 0 byte.
Even a 0 byte. And so it never did any harm, but it was wrong. On macOS, it would never do any harm. You would never see any ill effects from it. But it was still wrong. And if you took it to some other operating system with another allocator that did not have that behavior, you could get bugs. You could get incorrect behaviors.
Mm-hmm.
And so I was quite impressed when I did this, because it was like, whoa, I had never found that bug.
That's a fascinating one too, because the first time you run a tool against your project, you're both thinking, oh, well, my code's perfect, surely it won't find anything. But on the other hand, you kind of hope that it finds something, because otherwise, if you don't already know the tool and don't already know that you can trust it, then you're like, well, did it actually work? If it didn't find anything, did it run on my code? Yeah.
Well, the good news is that at the time, the libc++ test suite took about 20 minutes to run. And when I enabled ASAN, it took 90 minutes to run. So clearly it was doing something.
Right.
Okay. Go ahead.
But yeah, I'm really happy that Microsoft has got this technology in their compiler now, and even happier now that people who exclusively use the Microsoft compiler can turn this on. And I want to encourage everybody to do it, because the way ASAN works, it pretty much, the idea of something being a false positive is just not in its vocabulary. Every time ASAN goes off, there's a bug there.
Awesome.
Yeah. All right. The next thing we have is this is actually a update of RML UI, but I don't think we've talked about RML UI before. But it's a HTML CSS UI library for C++, which is pretty neat.
I had to spend like 5 minutes staring at this to even understand. I'm like, wait a minute. Why am I writing HTML with C++? What is this? Is this related to Inscription? No, it's their own UI kit, and they have a couple like little examples here on the GitHub page. So it's like it's mostly for video games. If you want to have like a menu page with your game, this is maybe a really easy way to put that together. Or if you just like HTML and CSS, you can use it as your interface description language. Or it's not an IDL, it's a UML. Or no, that's a bad word too. What is it? What's the word am I looking for? It's one of these
markup language.
It's a markup language for interfaces. Yes.
Yeah, it looks like it's really easy to do data binding between your HTML code and C++. So that seems like it's pretty powerful.
And sprite sheets. It looks pretty. It's pretty crazy.
Yeah.
Yeah. I've never used anything like this, so I don't know how it compares to anything else. But the data binding it looks pretty slick.
Yeah.
Although model view controller kind of stuff is really, really hard to get exactly right. It's really easy to get approximately right. Just as a side note, Sean Parrott did a whole bunch of research on this back 10, 12 years ago and ended up writing a couple little libraries called something in Eve. I can't remember what the other one was. I don't think it was Adam, and it was all about expressing constraints in dialogues and hooking up models and views and proving that there were no feedback loops and so on.
Yeah, the kind of thing that's really hard to get right when you're using a GUI, when you're writing a GUI, that is.
He was inspired because basically every release of Photoshop, there were a couple of dialogues that they kept rewriting because people would report bugs against it. When I do this thing over here changes and it shouldn't.
Mm-hmm.
And he ended up discovering that the reason that is because the way it was spec'd was inconsistent. And so now he writes the constraints in some little domain-specific language, and it generates the UI elements and the interrelationships automatically. And in the domain-specific language, it will complain if they're inconsistent.
Mm-hmm.
Or if there are feedback loops. But anyway, I digress. Sorry.
That was a good digression. Okay, and then the the other library we have here is called Not Enough Standards. And this is a little C++ 17 and 20 header-only utility library. And look like there were a couple neat things in here, like process management and shared library loading. So just a couple things that you're not going to find in the STL, but might be common enough that you want to have from a library. Yeah.
The process tool really caught my eye to just be able to very easily launch something and then get standard error and standard out from it cross-platform. Mm-hmm. I mean, I know there's boost process and queue process, but you know what? For the project I'm currently working on, I don't want boost or Qt in there right now.
Heavy. Yeah.
It's a bit much. And if there's and it's what's funny is just like last week, I was Googling around, like, I know there are other process libraries out there and I couldn't find any until I stumbled upon this one.
Yeah. Although what you said is actually a fairly common thing. Yeah, I don't want boost in there because boost is huge. And I understand that. But really, Boost is a collection of libraries, some of which are very large and some of which are very small. And so, and they're not all completely interdependent. There's a core group of a few libraries that everybody depends on, like the Boost configuration library and things like that. But you can use little bits of Boost without having all of Boost around.
Sure.
Yeah. Yeah, and I had not yet, on this particular project, I had not yet pulled in any kind of package manager or anything like that. And I have now, so it would be relatively easy for me to just say, with Conan, I just need Boost process, and it would sort out the details.
Yes.
I looked at Boost process a long time.
Just saying, that's a little bit of a hot button for me.
Yeah.
Like, Boost is huge. Yes, it is, but nobody uses
all of it.
Right.
All you need is Boost algorithm. Everybody knows that.
Okay, and then the last thing we have is an announcement for Meeting C++ 2021, and it will be held online from November 10th to 12th. Submissions are now open until the end of June, and you can also go ahead and get your tickets now or register as a student. So that's coming up in November.
I think it's probably worth pointing out too that NDC Tech Town, which is in October, has officially said that they're planning to be an in-person conference, and there hasn't been any official press release or anything that I've seen from CppCon, but the website is officially updated to say that CppCon at the end of October is going to be both virtual and in person.
Right.
I don't know about other conferences at the moment.
I'm sure we'll be seeing more announcements like this, and I have a feeling we'll see a lot of mixed virtual and in-person ones this year. Yeah.
The problem is that these kind of conferences, they have long lead times, long planning times, and so we're having to decide now in May, or actually probably last month in April, about things in November.
Yeah.
And you're just kind of guessing.
Yeah.
And there's lots of all of your catering and all that stuff you have to start setting up. Right.
Okay. Well, Marshall, we've talked a lot about the C++ ABI on some recent episodes, and Jason put together a video on C++ Weekly as well, where he had some of his own thoughts on the C++ ABI. But one thing I'm still kind of surprised by is whenever I see a discussion on Reddit or something like that, I actually still see a lot of comments about people who just don't know what the ABI is.
And like a quarter of people who think they know that it is are bringing up things that have no relevance, it seems like often.
Yeah.
So maybe to start off the discussion, we could get your explanation of what the C++ ABI is and why it's important.
Okay. Well, I'm going to actually go a little bit off script and say, not that we have a script, that say that ABI is really a really lousy name for this.
Okay.
There are multiple things that when people talk about ABI that that they mean, and the discussion that we're going to have really applies to none of them. But let's just start with ABI stands for Application Binary Interface, and it's really it's a way of defining, how parameters are passed and, how to return and structured layouts and how exceptions are handled and so on. And that's what, technically what ABI means. And usually that's a function of the platform or maybe the compiler on the platform. So Windows has an ABI, Linux has an ABI, Mac OS has an ABI, Android has an ABI, iOS has an ABI, ZOS has an ABI. Okay, and for Linux, for example, and for Mac OS, there's this really nice document called the Itanium Abi Specification, which you can Google for and find, or Bing or DuckDuckGo or whatever you can search for. Sure. But that's not what people really want to talk about when they talk about standard libraries and ABI breaks. Okay, and that's what really the discussion that people are having right now. And what that means is really we want to be able to change things in the standard library in a way that is incompatible with existing compiled code. I gave a talk about this at, I gave a talk like in March, a very late CppCon talk, and then one just 2 weeks ago at an expanded version at C++ Now about what this all means. And I spent probably 35 minutes talking about the one definition rule in C++. Mm-hmm. For those of the people who are not familiar with the one definition rule, basically C++ says that if there's a place where you have two different definitions of the same type or class or struct, and they differ, and there's some place you can see both of them in your program, then your program is with the delightful acronym IFNDR, which stands for ill-formed, no diagnostic required. This is a horrible thing. Okay, IFNDR means that your tool chain is allowed to put out an executable that can do anything. Okay, it's undefined behavior when you launch it. It's not undefined behavior maybe if you do a particular thing. It's undefined behavior when you launch it.
And there's no warnings or feedback from your tools.
No warnings, no feedback. And there's a reason for that. Let me run through 3 scenarios and I'll show you. Suppose you have 2 definitions of a struct. Okay? Different layouts. One of them has 3, the other has 2, say. Okay? They're in the same translation unit. Right? Fine. The compiler can notice that and can give a warning or an error. Right? And most compilers do. They're in different translation units, and the linker puts them together. The linker creates an executable from these 2 object files. It's theoretically possible that the linker could, in fact, tell you that if all that information was embedded in the object file, which is not. Mm-hmm. Really, what's embedded in each object file is the way to deal with, we're going to call this struct pair, just for fun. Right? There's one pair here that has 2 fields, first and second. There's another pair over here that has second and first. Just say it, right? Something like that. The linker could, in fact, if it had all the information, it could warn against that. Third scenario, okay? You have 2 different translation units, one that gets linked into an executable, one that gets linked into a shared library. Okay, they're different. And they get passed back and forth, say. There's no way your linker can tell you this. There's no way the compiler can tell you this because the program is not assembled until you launch it. Mm-hmm. The program loader would have to do this for you. And all that information is gone at that point. And so this is why, it's IFNDR. There isn't any one place that you can, in fact, catch this. Because, the program as such doesn't exist in these days of shared libraries and so on, and plugins and whatever, until the program is launched and your tools may not even be on that machine. In the case of commercial software, right? You have an app. You sell an app. You give it to a customer. He puts it on his machine. He launches it. There's shared libraries that this app uses that are on his machine. You're not involved at all. Anyway, so the talk I gave, basically I went around and gave a bunch of examples of ODR violations, some of which are obvious, like a struct with 2 fields named first and second and first, and they're different types, right? I think we can all agree that if you pass these back and forth, what happens? One of them, code of this thing will say, I need to access first. And it says, great, it's at offset 6 in this struct, and it's 4 bytes long. Boink. And this one says, no, it's at offset 0, and it's 5 bytes long. You're going to get the wrong answers. You're going to be confused. If they're different sizes and you have an array of them, right, or a vector of them, and you try to access the elements of the vector, right? They're going to be in different places, and you're going to get confused. But there's lots of examples of that. That's just a really obvious one, making something bigger or rearranging fields.
Right. And
so there's not any way to catch this. That's the ugly part of this. There are some people, there were some papers at this last in-person standard library meeting or standard committee meeting in Prague a year ago, 15 months ago, something like that, talking about changing the ABI of the standard library. And Titus Rinters wrote one proposing, here's a whole bunch of things that we could do if we could change the standard library ABI. And some of them are minor. I mean, they're all improvements, don't get me wrong. Some of them are minor. Some of them, a couple of them could lead to major performance improvements for certain classes of programs. We know now, in these days of machines with big caches, we now know that it's much more important than we thought 25 years ago to make sure everything's cache aligned. Mm-hmm. And so the unordered containers could be made much, much faster if the data structures were rethought, relaid out to always hit on cache lines. And Google's Abseil library does a bunch of this. That's the big performance advantage, but there are lots of, and there are a lot of little things too. And don't get me wrong, these are all good improvements. These are all the kind of things that we would like to be able to do. But we don't want to just break every C++ application in the world. Actually, there are some people who do want to do that. I have seen people arguing that users who won't rebuild their software every 3 years are holding the C++ community back. Really. Mm-hmm. My easy response to that, of course, is users have their own deadlines and own timetables, and and besides, I could talk about my mother who passed away 6 months ago, so I'll talk about my daughter instead. My daughter uses a bunch of software written in C++. You tell her she has to rebuild it, she'll say, "What? Rebuild? I didn't build it." Right? The assumption is among the people who say that they should just rebuild their software every 3 years, that everything you have, you can build from source. And there are people who live in that world, okay? And for them, a stable ABI is of much less value.
But I just want to ask, if the C++20 ABI had been completely destroyed, why would that affect your daughter's software at all? She still has binaries with libraries that are already installed on her computer, that it knows how to find these libraries that are stable. Right. Why would that affect her?
What happens when she gets a system update from Apple that includes a new standard library dilib?
I mean, I have like 18 of them from Visual Studio installed on my computer right now.
Yeah. Apple has one.
Okay.
So
Apple doesn't have any way of versioning their standard libraries.
They have chosen not to do so. That's correct.
I see. Okay.
So let me give a very specific libc++, because I'm very familiar with libc++. libc++ has two different versions of standard basic string in it, and they're ABI incompatible. And the reason for this is because after various people, including Apple, libc for several years, some people at Google discovered that you could make changes to the way standard basic string is laid out in memory to take advantage of cache alignment.
Mm-hmm.
And this was a surprisingly large win for things that did a lot of string manipulations. Enough, since Chrome kind of lives and dies on benchmarks, they discovered that this one change to way down in basic string got them 2% on their JavaScript benchmarks, which is a really, really big number. I don't know if you follow those, but 0.2% is a big win. 2% is 10 times that. And so libc++ now has two different versions of basic string in it. And they're controlled by an if-def, a set of if-defs. And people who ship the library can choose which version of basic string they ship. I can tell you that Apple has continued to ship the old one, the original one, in names of compatibility. But every time they define a new ABI, i.e., when they create a new platform, and they define, which effectively lets them define an ABI, they switch over to the new and improved version of basic string. The first one of those was when they introduced the 64-bit iOS devices.
Mm-hmm.
The second one of those was just this year when they introduced the ARM-based Macs.
Okay.
Those kind of things. But yeah, libc+ has a dozen, going on 15 now, different macros that control ABI changes.
Wow.
Yeah, that was the first one, was alternate string layout. Okay. And there are people like, say, the Chrome folks who embed their own version of libc++ inside the Chrome binary, inside the Chrome package. They turn them all on because they want them all, because they don't care about it. It is of no value to them, because
right.
all it has to be has to match the build of Chrome that the dilib is inside. But let's see. I see alternate string layout. Allow incomplete types in deck. Get rid of a bunch of undefined behavior. A space optimization.
Get rid of a bunch. I'm sorry. Did you say one of the flags is get rid of a bunch of undefined behavior?
Well,
that's a build option.
There's like 4 of them, and the reason is because there were some obscure calls in, like, remove node pointer that was introduced in C++ 17 that had some undefined behavior in it. And to get rid of them, we had to change some structures in the existing containers, which was ugly.
So just out of curiosity, though, if I just download libc++ and compile it right now, does it default to all of those? Does it default to binary compatibility, or does it default to no undefined behavior?
Yeah.
It binary compatibility.
It defaults to binary compatibility. Okay.
Yes.
And is that part of these binary compatibility things to be binary compatibility with libstd++ also?
That was, in fact, well, no. Okay.
Okay.
There were a couple of goals back in the day for libstd++ compatibility. In particular, there was the goal that you should be able to build code with libc++, build code with libstd++, link them together with both of the libraries and have it work. And in particular, you should be able to exceptions from one side and catch them on the other.
Okay.
But that's about the only part really there that where there's compatibility.
So that does.
You can't pass a std string, for example, from libstd C++ to libc++.
You can't.
Cannot.
Okay.
But you can pass a std exception, because we did a bunch of work.
That was intentional. That works. Yeah. I feel like that should be worthy of a pause here for a moment, because Like most things, right? We get stuck in our habits, and we, oh, well, I heard once that libc++ is compatible with libstd++. I am sure there are people listening to this podcast right now that are linking both into their application, either intentionally or unintentionally, without realizing that they probably have some sort of ODR violations of some sort going on.
Well, except that they really don't. And the reason for that is libstd++ puts all their symbols in namespace std, and libc++ puts them all in an inline namespace called std:__1.
Right, okay.
So when you link them together, they all have different names.
Okay.
Except for the exception types, which all live in namespace std. So that's how you can do that. You can mix code with both of them and link against both of them, and it's fine, because the std::: basic string will be the libstd++1, and std::__1: basic string will be the libc++1. And the compiler and the linker knows that they're different.
It looks like a duck, quacks like a duck, but it's not a duck in this case.
It's not a duck, yeah. Sometimes an ABI break is really, really subtle, and it's very annoying when you discover this.
Mm-hmm.
In C++03, we had pair, right?
Mm-hmm.
It's used in map. It's used in an ordered map. It's pair, right? Has two fields, first and second, and the copy constructor of pair was defined in C++03 as assign first to be right-hand side dot first, and assign second to be right-hand side dot second. That's the copy constructor. Done. Somebody got the bright idea of, for C++11, because we had this spiffy new language feature called equals default, that we should redefine pair's copy constructor to just say equals default, because the compiler will generate, it'll copy assign first, it'll copy assign second, and we're done.
Mm-hmm.
It's shorter, and it's obvious that that's what's going on, that there's no games going on here. And in fact, the compiler will generate the exact same code. It's all good. Except that this opens up a new possibility. And the new possibility is that in C++11, when you say equals default, some specializations of standard pair are now trivially copyable.
Mm-hmm.
Okay.
Like a pair of ints.
A pair of ints, right, or a pair of shorts or something like that. And on some platforms, Itanium, a trivially copyable data type which can fit into a register is passed as a parameter in a register instead of on the stack. And so if you had, say, a pair of short, and it had a non-trivial copy constructor, which is what C++03 had, it would get passed on the stack. And if you had one with a trivial copy constructor, as in C++11, it'd get passed in a register. And needless to say, if you had some code compiled with C++03 and some code compiled with C++11, they would get horribly confused, because they would go looking on the stack for something that was in the register, or vice versa.
I have a question that's not directly related to the overall topic of conversation, but I just found myself wondering while you're describing this problem, why did C++98's standard pair have a user-defined copy constructor at all?
What should it have been then?
It should have been left out. The compiler generates the copy constructor for you if you don't define any other special member functions.
I'm not sure that's true for C++98. So, but anyway, I don't know off the top of my head.
Okay.
The aggregate rules have keep changing. So don't know.
Okay, that's fine.
But yeah, in C++11, yeah, equals default is definitely the right thing.
Right.
But libc++ goes to some work to actually make sure that unless you flip a particular compile time thing, that no matter what, pairs are not passed, are not trivially copyable, because we don't have to do that. Anyway,
so you mentioned how at the Prague meeting that there were a bunch of proposals mentioned that, were we able to do an ABI break, we could get these performance improvements, such and such. Has there been any discussion about how ABI breaks could be handled in a safer manner? Because you're talking about some of these bugs that are, really difficult and they only happen at runtime. Is there any way we could be better about catching these sorts of things so that they're not just awful runtime bugs that would crash your application?
I wish. I really wish. And to me, that is like the key of the whole matter. If we had such a way to do that, I think a lot of the objections to changing the ABI, I'm going to continue to use that term even though it's the wrong term.
Yeah, that's fine.
Changing the binary layout of things in the standard library is going to be really hard. The idea of just, people's programs will crash and that's their problem is, to me, just a non-starter. Obviously, this can't be done at the tool chain level because the tools aren't involved when it needs to be detected. One of the suggestions that somebody has made, but it's just a suggestion that I haven't seen anybody actually try it to see how well it would work or how it would scale, is that to change the name mangling for things compiled with, say, C++ 26. So that,
it's basically the solution that the standard libraries do that you were just talking about. You're hiding it in a different symbol, basically.
Yes, but then you've basically bifurcated the C++ community. You have old binaries and new binaries, and people have to actually make a choice for compatibility, or whatever the benefits are.
Mm-hmm.
And the other thing is that we need to, if this is going to happen, there needs to be a good solution here, but there needs to be a lot of people involved in discussing this. People on the committee can say things and write things into the standard, but if standard library implementers don't implement it, it doesn't matter. And even better, if system vendors don't ship it,
I'm curious if there was like a historical change here, because there was the era before C++, well, actually before what, 2013 or whatever, that Visual Studio broke ABI with literally every release.
Yes.
And GCC also used to break ABI with every release.
Okay. The second one of those I have some knowledge about.
Okay.
If you Google up, GCC ABI breaks, you will discover that there's a list of like a dozen of them.
Right.
And only one of them had to do with the standard library. All the rest.
Okay.
Yeah, there's like 5 or 6 of them where we changed the name mangling for null pointer because we had it wrong last time. But most of them were changes to name mangling of very specific things. But we do have an example from libstd C++, and that comes from C++ 11.
Okay.
In C++ 11, the standards committee knowingly changed the specification of basic string to make it so that copy on write strings were not actually standards compliant. They didn't say you can't implement copy on write strings, but they specified it in such a way that basically you couldn't do it. You couldn't implement copy on write strings in a standards conforming manner. And there were good reasons for this, right? This was right about the time I joined the standards committee. There was Multi-threading was coming. Multi-threading was here in C++11, and copy on write strings do not play well in a multi-threaded environment. You have all sorts of race conditions, or you have to be really, really aggressive about copying things on the possibility that something might write. And so, for example, calling begin on a string, on a const string, calling begin and getting back an iterator, not a const string, but calling begin on a string should require a copy because you might write through that iterator. And then suddenly begin becomes, you can't make begin no except because it's got to allocate memory. And anyway, and so libstud C++, the people who work on this sat down and thought really hard about how to do this. And they implemented a second version of basic string that was C++11 compliant. And then they modified their compiler and did a bunch of very strange things in the standard library. And don't get me wrong, when I say strange, I mean unusual. I don't mean wrong or anything like that. But they did a lot of very strange and clever things, both in the compiler and the library, to allow people to use either one of those string implementations or both, even in the same process. And then told people, this is how you get the old behavior, this is how you get the new behavior. And let their users choose when or if to upgrade. Mm-hmm. And this was still kind of a disaster. Okay. I still see posts on Stack Overflow where someone says, I wrote this program using libstd C++ and it crashes all over the place. And every now and then it turns out, oh yeah, you have this standard library that's built against the copy on write strings, and your program is built against the non-copy on write strings, and you're passing them back and forth. And it just doesn't work. Mm-hmm. The last time I saw a question like that on Stack Overflow was May of 2020, 12 months ago. I know two organizations that steadfastly refused to turn on the non-copy on write strings. One of them actually did last year. It took them to 2019. Another one is like, yeah, we're planning on doing that next year.
So are they using C++ 17 right now? Or are they still using C++ 98 or?
They're using a whole bunch of different versions, they're working on several different systems. Some of the stuff gets compiled as C++ 98, some is 03, some is 20. Some is 11, 17, 14. But yes. And so but those systems that they're using libstd C++, they're still using copy on write strings. They're planning on switching over eventually. This has been, it's kind of down to a dull roar at this point, but this has been going on. There have been this more or less steady stream of people running into this problem for the better part of a decade.
If you don't mind, I'd like to jump back to the story about pair.
Mm-hmm. Sure.
What was the conclusion of that? Does that mean on some platforms, pair of trivial objects is not trivially copyable still?
Yes. Like on macOS.
Okay.
And the reason for that is specifically to defeat the
ABI break problem.
Yeah, the ABI break. Yes.
Okay.
libc++ and libc++, unless you set the particular ABI break macro, it inherits from an empty base class with a trivial but empty copy constructor.
Right. Just to give back that behavior.
To get that behavior, exactly.
So it's okay. Yep. All right.
Yes. So I want to give you a scenario that I think is interesting, and that is to a thought experiment. I talked about this in my C++ Now talk. It's like, suppose that we'll pick on Apple. Suppose Apple, the standards committee says, we're going to make an ABI break for C++ 23. We're going to change the way boobity-bobbity works.
Mm-hmm.
Okay, and it's an incompatible change. Okay, and Apple says, okay, fine, we'll ship that. And so we go to somebody who is a graphic artist. They use Photoshop every day, right? And they're working along, and they get their notice that, oh, there's a new version, macOS 11.3, whatever it is. Weed, macOS Weed, since Apple always uses it at their announcements. First they claim that the next version of macOS is going to be macOS Weed, and then they say, well, no. But anyway, and so they say, okay, well, fine, I'll go and upgrade this because it has a compelling list of features that I want to use. And say, fine. And there's a note there that says, oh, yeah, hey, make some changes to the C++ standard library. You'll need to update all your programs. Okay, fine. So they update their system, and then they go and go to Adobe and say, I need a new version of Photoshop for this, and Adobe is right on top of it. It says, absolutely, because you have a subscription. Here's the new version. We're all good. And they open up one of their Photoshop files to start working on it. If they're really lucky, none of their plugins load.
Mm-hmm.
If they're unlucky, moderately unlucky, Photoshop crashes on launch because it's trying to load all the plugins that this person uses, and they have the old ABI. If they're really unlucky, Photoshop will appear to work just fine, and eventually, they'll do something and it will crash or corrupt their document or something. And so they say, oh, I have to upgrade all my plugins. Great. How many do I have? About 40. I checked with some people at Adobe, and it's a perfectly reasonable number of plugins for people who use Photoshop every day. 40 plugins from, say, 15 different vendors. Okay, I have to go contact all 15 of these vendors and get upgrades for every single one of them. And some of them will say, oh, sure, here. And some of them will say, yeah, I have a new version. That'll be some upgrade fee. Some of them will say, oh, yeah, I should probably do that. I'll put that on my to-do list.
Mm-hmm.
Some of them will say nothing because they don't answer. A surprising number of Photoshop actions, Photoshop plugins come as a result of, somebody's master's thesis. But that's not an experience that Apple wants. That's not an experience that Adobe wants. That's not really an experience that the libc+, as a standard library implementer, that's not an experience I want either. I want to, we don't want people thinking that software written in C++ is inherently unstable and it's liable to break anytime you change anything on your system.
I guess to push back a little bit, though, I mean, Adobe comes out with new versions.
Yes.
So if they come out with a new version where they might be making API changes or adding new APIs,
mm-hmm.
That could be the time to upgrade to the latest change in the ABI.
They could be, but the question is that if Adobe has traditionally been very careful not to make incompatible changes to the plugin API.
Mm-hmm.
So existing plugins continue to work.
Right.
I would like to see some way forward of evolving. I'm going to break evolving. Things in the standard library, and some of those are binary changes, some of them are source changes, and so on. But there's a lot of people who have stakes in this. I hate the word stakeholders, so we'll leave it out. But there's a lot of people who basically are, between the standards committee and the users, and they all have opinions, and they all have their own motivations. And so, to get something from the committee to the users requires cooperation of all of those people, all of those organizations. And so they all need to be on board.
So do you see, I'm sorry.
I think we need some way of, I guess, evolving the standard library. And the Java way to do it is just to create a new class, call it da-da-da-da-2 or something like that, and say, this old one, don't use that anymore.
The last time I programmed seriously in Java was in like 97 when they were doing that. It felt like every month as they were coming out with new things.
Yeah. Right. If you talk to Jonathan Wakely and the rest of the libstud C++ people, you find that they come down very, very strongly on the side of compatibility. They're still shipping TR1. Okay? Technical Report 1 from 2005.
I think Visual Studio Standard Library also has that hidden away in there.
They still have HashMap, which was, again, a pre-2011 unordered container.
Right.
They're very, very big on compatibility.
So do you say, and well, I don't want to put words in your mouth, but until we have a solution, is there any way at all to break ABI in the standard library to move forward? Like, would you say, no, there's no option here until we have a good solution in place? Or would you say, sure, in 2035 we can do it, or whatever?
It depends on the situation. It depends on the people involved or the organization that's involved. Okay. I mean, obviously, like I said earlier, when somebody defines a new ABI, right? You have a tabula rasa. You can do whatever you want. Right? When you have a limited user base that can be responsive to changes in an ABI, go for it. The Linux people can do that, although they still run into problems with things built for, say, Red Hat 6 and trying to run them on Red Hat 8, because you have pre-C++ 11 strings, say. But the Linux where you build stuff, for a major release, you build everything from source. You can do that. For Google, for example, where famously every single build of their software is everything from scratch, it's a stable ABI is
irrelevant.
Has no benefit, right? So they can change it every single build.
So does Boost have a stable ABI?
Boost,
I guess that would be no if you have to think about it, right?
Well, it's a little more nuanced than that. Boost does not promise a stable ABI.
Okay.
In general, it has a stable ABI unless there's a good reason to change it.
Okay.
So, for example, the Boost outcome library, I think it was, right, announced 3 releases ago, a year ago, that there was major changes coming down the road, which would involve basically, an ABI break. And they announced it a year ago, and then they announced it 2 releases ago, and they announced it last release, and this release that was last month had the new code in it. So the short answer to that is no, but the ABIs of things don't change absent a good reason.
Okay. What makes Boost then? How is that different from the standard library? Is, I guess, the question that I want to ask.
Well, I'll give you one easy answer, and that is that you can rebuild. You have the sources to Boost. You can build it. You can get sources to libc++, but unless you know how it was built at Apple, you're going to have a kind of a detective job to figure out exactly what options were used.
Which you'll never find out because it's Apple.
You can do it by inspection. There's only, what, 2 to the 12th of them. And
Right.
you can eliminate many of them off the tick.
I guess what I'm hearing is with Boost, I can still choose to use the older version of the library as long as I want to.
Yes, you can. And you can build old versions of the library. Yes.
Right. On whatever compiler I want to, with against whatever standard library or whatever.
But if you get your standard library from your system vendor,
Mm-hmm.
that's what you're going to use. When libc++ was new, people were like, "Oh, look, I can replace the standard library implementation on my Mac with something that has newer features." And Howard wrote a nice article about it, basically saying, "Yeah, that's a great way to make your Mac not boot. Replace the standard library with something you just built. That's if it's exactly the same, great. But if it's exactly the same, why are you replacing it? And if it's different, have you investigated all the places that use the standard library in macOS and determined that your change isn't going to break anything?"
Right.
So yeah, that's not a recommended thing to do. But no, I wish we had a way to evolve the standard library that was better than the Java way, which is basically give things new names, new functionality, new names. That's the only one I know about that I can think of off the top of my head that isn't just change things, and if stuff crashes, well, that's not my problem.
No, and lots of libraries do that in general. They decide they're going to make a major break. They'll just call it. They'll change not just the version number. They'll change the library name entirely.
Mm-hmm. Right, and you'll have foobidiva 2.
2. Yeah.
3, 4. Yes, that's one way to do it. Now, Apple has spent a lot of effort over the years shipping various things they call fat binaries.
Yes.
That contain multiple versions of object code. And I suspect there's a solution there, but that's a germ of an idea. That's not a solution.
Right.
And the other thing is that Vitoro has a proposal called C++ epochs.
Mm-hmm.
That looks like it would also solve this, but again, at the cost of basically fracturing the C++ community. This would fracture it like 6 ways: 98, 03, 11, 14, 17, 20. When you build something with C++ 17, it lives in an epoch and it only links against code that's built with C++ 17. So if you needed a shared library like, say, I don't know, Neil Holman's JSON library, right? And you had code that was built with C++ 11 and 14 and 17 and 20, you need 4 copies of the library. Disk space is cheap, but it's not that cheap.
Right.
And disk space in the last 3 years has gotten more dear because everybody's moved to SSDs.
Right.
And those 16 terabyte SSDs are still too expensive.
A little bit.
So anyway, so I am, just to sum it up, I am sympathetic to the idea of improving things in the standard library. I like to do that. But the idea of just changing the behavior of things or the layout of things in the standard library and saying, if it crashes, it's your fault, I am very much opposed to.
Right.
Right.
And the idea that you could just rebuild your software is pretty much a non-starter for everybody who doesn't live in the open source world.
Well, I appreciate you bringing that perspective, and I certainly think there's some things you went into that we haven't really talked about in our past discussions on ABI, and definitely helps understand what some of the ramifications were. I definitely agree with you that we need to figure out some way to evolve. I'm just not sure what that's going to be, but hopefully the standards members are all thinking about it and trying to figure something out.
I don't have any good ideas either. I mean, I have a couple suggestions which could evolve into proposals at some point, but
Hmm.
that's all they are, just suggestions. Maybe we should look over there and think about doing things this way. But that's not a solution. That's an idea about maybe this would work.
It does sound like we do need some sort of standard proposal that will solve this problem. Like the standard has to define something that will handle this.
I don't know. There's a bunch of things that the standard does not talk about.
And this is one of them currently.
This is one of them.
Yeah, I mean, but you are talking about it by not talking about it. Something has to give at some point.
The standard doesn't talk about how compilers implement virtual functions. It talks about, I don't.
Yeah, but that doesn't stop the committee from changing virtual functions.
No, but all the standard does, it talks about this is the behavior of virtual functions.
Mm-hmm.
If you add a virtual function to an existing class, okay, everybody implements the same way. You have a static member variable, which is a pointer to a bunch of function pointers, right? The vtable. Where does that go? Does it get added?
Defined.
It goes on the end of the table? Does it go in the middle? Are the functions in the vtable ordered in some specific way? The answer is clearly yes, because it needs to be consistent.
Right.
But it could be, alphabetically. It could be in order of declaration. It could be reverse alphabetical. It could be inside out. But I happen to know that for GCC and Clang, it's in order of declaration.
Right.
But that's done that way for compatibility with existing code. That's there's nothing magical about that, except there's a lot of code out there that expects that. And so, these are things that are not specified anywhere in the standard at all. The ABI documentation, the Itanium ABI doc that I talked about, not part of the C++ standard.
Right.
And it's not even an official standard anywhere. It's this collaborative documentation doc that implementers refer to and edit when they find mistakes in it or things that are unclear. When I had to implement the exception handling stuff in libc++ ABI, I referred to that a lot and asked people questions.
Okay.
Yeah.
Well, Marshall, it was great having you on the show.
And we're out of time.
Yeah.
It was great talking through this. I really appreciate your perspective on this, and hopefully starts to move the conversation forward.
Hopefully.
Yeah.
Any other questions for me?
I think we're
Not
good
at the moment. Yeah. Thank you.
No problem. You got any questions? You send me an email. You know how to get a hold of me.
Right.
Rob knows how to get a hold of me.
Yeah. Okay. Thanks, Marshall.
You're welcome. Thank you.
Thank you.